Thank you very much for inviting me to this workshop. So here I'll be presenting some of our efforts that we have been continuing in the lines of safety algorithms in generative AI. And while I'm presenting this work, this is a collaborative effort by a bunch of students of mine, as well as a few collaborators from Microsoft back in India. So I'll be talking about four works. The first one being Tech Hazard QA. So this will be presented in ICWSM 2025. So before going to the details of the problem, I just want to motivate with this example slide. So jailbreaking is a very common thing these days, and people across are very worried about this problem. So and most often we see that if you have something like a text prompt, most of the LLMs are good enough in identifying that there is some issue with a prompt like this, and therefore they are not going to answer. However, if you slightly change the prompt settings to ask it to write in the form of a code or a pseudocode, the moment you do this and feed this prompt to the LLMs, it starts giving you a set of guidelines as to do that same harmful thing. So the harm, while it is not elicited by a text prompt here, as soon as you change the prompt into an instruction-centric, that's how we call it, instruction-centric prompt, immediately it starts, enumerating a set of steps for going ahead. So, and it's not a one-off case. Like we tested it across multiple language models, and we observed that this is a common trend, and most often they are jailbroken using these instruction-centric prompts. So like what could be a solution? So we tried and came up with this solution in AAA 2025, and we call this a sheer to sorry kind of a transition. Generally what happens, like most LLMs are very confident in answering your questions and even harmful questions, and they start with the word sure. So like if we could make this to transition to sorry, and how we do it is by some standard approaches using the first idea is to use function vectors. That is where you try to move the harmful output of the model to some safe output, which is through a set of safety demonstrations, and then we use control text generation using model arithmetic mechanisms, and based on that, like using these two steps together, we try to actually reduce the amount of harmful content that a language model elicits. And we see that using this simple technique of joining the safety vectors as well as the control text generation, we are able to reduce the harmfulness or the attack success rate, as we call it, of the models. And this is not only true for the general case, this is not only true for this particular set of already available data, but also the data that we proposed, the Tech Hazard QA, which has a lot of instruction-centric prompts to make you elicit harmful content. So there also we get a very good benefit. So the next one work that we wanted to look into is the cultural aspect of harm. And as we see that if you put your harmful content or the harmful prompts in a cultural angle or a culture, if you place them in a cultural context, then you see a lot of harmful texts that are being elicited by language models. And on the picture that you see here, the intensity of the red color shows like the amount of harmful content that is being generated by Llama 2 across the different cultures of the globe. And we tried to come up with some very simple solutions. So we see that across multiple language models and multiple cultures, around 11 cultures, we see that there is a lot of harmful content that is elicited, which is shown by the attack success rate. And finally, Like, we came up with some preference tuning measures to stop this. And this is the last work where we use language specific vectors to this is also, the idea is borrowed from function vectors. We use these language specific vectors to steer the model towards safety, but for natural language in a multilingual setting. And we take like multiple languages, and we show that the attack success rate actually drops from a very large, like 60%, to somewhere around 10% across multiple languages. Thank you very much.